The next question is called copy. Create a method named copy. This method will take two-dimensional arrays of integers as a parameter. The purpose of this method is to return an exact copy of the array passed as a parameter. Make sure you understand the concept of exact copy, which means that for every index that you have in that array should be duplicated exactly as it is. The copy method, it's quite important because remember that in Java we pass values what we call copy by reference, and that is a concept that we need to recognize when we want to create a duplication of an object. The question is provide an array of integers as an argument. And the only thing you have to do is to create an exact copy of A. Some of you might think we'll create B, which is nothing but A, and then return B, professor, and that'll do. So if we try to test this, we expect B after calling the method copy with the array A. Now we can test this thing by using before and after. I'll print A, and then I'll print B. Now I want you to pay attention when we do something to B. Suppose that B at position 0, 0, I'll put the value of 224. Now, if I try to do the same printing, this time after we actually do the population and modification on line 8, let's see what happened. Let's do that. But before that, let's just keep something similar like a 4x3 arrays. So I'm going to put here a system.println A and print system.println B. In similar fashion, it will be after the execution of these items. Let me just clear my screen. Let me save, compile, and run this program. So here, there. Before, we have an array A and array B. Notice that it's an exact copy. But notice that after I modify the array on line 10, that also modify A and B. So when we create a copy, you need to be careful how you address that copy part. Notice that here, what we want to do is in the copy method is we do create B, but based on the same dimensions that we have as an A. That's where we put A.length and the number of columns that length. The question is, professor, what value we put here since we don't know? In two-dimensional arrays, there exists something called ragged arrays. Ragged arrays are basically a dimension that are not uniform for each row. You can assume that all rows have the same dimensions. So we can say whatever is at position 0 will have the rest of the indices. This is a very dangerous assumption because we don't know. Mostly, that's how everything is going to be in your application. But again, the best way to do it is to copy one by one of those indices, which is an array, into the other array. The next thing we have to do is nothing but navigate through all the length of B or A for the rows, for the columns. And the only thing you have to do at position B, I, J is to provide whatever was in the array at position I, J. This way you're duplicating exactly the same value that you have in the old array to the new array, row by row, and for every time we revisit each row, column through column. I'm going to save, compile, and run this program so you can see the difference now after we run. Let's zoom in. At this point, notice that we have right now the array A, which is composed of this, and array B, which is composed of that. Now, after modifying the 224 on array B, notice that only get changed in array B and not in A, because we're doing exactly in the array position from B, not in A. Remember that Java copies by references rather than just copy by value. That you can have access to each independent reference in memory. Another interesting part here is ragged arrays, which are the dimensions for each row that you have. You can assume that they're all uniform. However, it does not always guarantee you that case.